Welcome to another video. So today we have an interesting type of an exponential equation where we are required to find the value of x given that 4 raised to x is equals to x raised to power 4. So I'm going to take you through step by step up to the final solution. So straight away into the solution, I'll start by inspection. I'm going to try testing the values of x, which when I substitute here, it's going to give me the output. So let us start by when x is equals to 0. I know that 4 raised to power 0 is equals to 1. And on the other side, 0 raised to power 4, of course, that is 0. So 0 cannot satisfy this particular equation. So when x is equals to 1, 4 raised to power 1 is equals to 4. And 1 raised to power 4, of course, is 1. I'm going to go ahead. When x is equals to 2, I know that 4 raised to 2 is equals to 16. And 2 raised to power 4 is also giving us 16. So we have actually found that the first value of x which satisfies this particular equation is x is equals to 2. But do you know that we have other values of x which we can satisfy this particular equation? We're going to go ahead and solve it even using the W Lambert function. So the second method, I'm going to call it method 2. I'll start with the 4 raised to power x is equals to x raised to power 4. So this can be written as 2 raised to power 2x is equals to x raised to power 4. Then I can comfortably take the square root on both sides. So when I take the square root on both sides, I'm going to end up with 2 raised to power x is equals to, of course, when I take the square root of this, you're going to get x raised to power 2. We're going to go ahead to find also the square root on both sides. So when I find the square root on this side, I'm going to end up with x is equals to, on this other side, square root is equals to plus or minus, of course, 2 raised to power x over 2. So here it tells us that the output can either be a positive or a negative. That is what we want to compare. So that tells us that the value of x is equals to 1, positive 2 raised to power x over 2, or x can either be equals to negative 2 raised to power x over 2. So for the first case, let us start with x is equals to positive 2 raised to x over 2. That tells us the value of x should be greater than 0. So guys, if you're watching us for the first time, kindly like this video, subscribe to this channel, turn your notification on. You also have a playlist. You're going to check out a similar question like this. So the first step, I'm going to introduce the ln on both sides so that I have the ln of x is equals to ln of 2 raised to power x over 2. So it shall be ln of x is equals to x over 2 to the ln of 2. Taking x on the other side, I'm going to get ln of x divided by x is equals to ln of 2 over 2. So this can be written as, I'm going to take this up so that x raised to power negative 1 to the ln of x is equals to ln of 2 divided by 2. Next step, I'm going to introduce exponent on both sides so that I have the exponent to the ln of negative of x, x raised to power negative 1, multiplied by ln of x is equals to ln of 2 divided by 2. You recall that exponential to a natural log of x should always be equals to x. So when this is x raised to negative 1, then this is also x raised to negative 1. Rearranging, I'll start with this ln of x multiplied by this exponential to the negative of ln of x is equals to ln of 2 divided by 2. At this stage, from my Lambert W function, if you have the w of a exponential a, then this is equals to a. Then rewriting this to look at the same as this, I'm going to introduce negative on both sides of the equation so that it looks alike. So when I take the w of this side, negative ln of x multiplied to the exponential negative ln of x is equals to the w of negative ln of 2 divided by 2. Of course, when you take the w of this, you're going to get negative of ln of x is equals to the w of negative ln of 2 divided by 2. At this stage, I'm going to introduce exponent on both sides so that when I take the exponent of a natural log, I'm going to end up with I can take this on the other side so that I have x raised to negative 1 is equals to the exponential of w. X raised to negative 1 is equals to w of negative ln of 2 over 2, meaning that for you to get x, I'm going to take 1 over the exponential to the w of negative ln of 2 divided by 2. Computing this in my scientific calculator, I'm going to end up with x is equals to 2 for the positive value of x which was required. Now, recall that we had that x was is equals to negative of 2 raised to power negative x over 2. For this case, my x should be less than 0 since it is a negative. So for me to work it out, I'm going to take this negative on the other side so that I'm able to get the ln, so that I have negative of that is equals to 2 raised to x over 2, so that I should be able to find the ln of a positive number, but this side I have negative x. Introducing ln on both sides, I'm going to get, so that becomes ln of negative of x is equals to ln of 2 raised to x over 2. This can come down as ln of negative x divided by x is equals to ln of 2 divided by 2. Of course, this can be written as x to the negative 1 ln of negative x is equals to ln of 2 divided by 2. Then I'm going to introduce e to the ln of negative of x like that. But recall that I cannot take the, so having introduced negative and negative on that side, that is what I have. So I decided to multiply this with the negative and on this side with a negative, so that when I rewrite it like this, I'm gonna get exponential to the natural log of negative x raised to negative 1, which is this. So this can be written as, let me start with this, ln of negative of x multiplied by the exponential of, take this the other side, negative ln of x negative is equals to negative ln of 2 over 2. So guys, I want this to obey the w function, a to the exponent of a is equals to a. Then for this to look alike like this, then I need to multiply again by negative 1, on this side also by negative 1, so that it's gonna change to negative to the ln of negative of x multiplied by the exponential of negative ln of negative x is equals to negative, and negative disappears, and then I remain with ln of 2 divided by 2. So guys, I know you are still there. Kindly like this video, subscribe, comment, turn your notification on, and share. Then at this stage, I'm gonna take the w of both sides of the equation. So when I take the w of this, it's gonna remain as negative ln of negative of x is equals to the w of ln of 2 divided by 2. At this stage, for me to remove this ln, I'm gonna introduce exponent on both sides, and of course this can come the other side. I can divide with the negative so that I have the exponent to the ln of negative of x is equals to the exponent of negative w of ln of 2 divided by 2. When you take the exponent of a natural log, you remain with negative of x is equals to the exponent to the negative of w ln of 2 divided by 2. And of course, if you want the value of x, I'm going to divide all through by negative, so that you end up with the value of x is equals to negative of exponent to the power of negative w of ln of 2 divided by 2. So I'm going to come here and compute also this in my scientific calculator, and this is gonna give me a negative value of 0.7666469 and 596. I've just computed this using my scientific calculator. This can be written roughly to 4 significant figures as negative 0.7667 as the second accurate value which satisfies my equation. So that other method I've given you as the two values of x. One was x is equals to 2, and another one x is equals to the negative of 0.766. When you take this and substitute in our equation, you realize it satisfies that equation. Thank you for watching. Kindly like this video, comment with an alternative approach, and once again, thank you.